Has AI written any good science papers? What are the primary targets for the extremely large telescope? Which is scarier, finding aliens or not finding them? And Q&A Plus, what happens if you keep feeding a black hole forever? All this and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops into your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Alaskan ballistics. What is the first thing that you want to see studied with the Very Large Telescope? Are you talking about the Extremely Large Telescope? Because the Very Large Telescope is already in operation. That's the 4 8-meter telescopes in Chile, while the Extremely Large Telescope is the one that's in construction right now, and it's going to have a 39-meter aperture, which is much bigger. And like, what do I want to see? Well, it is a general tool that's going to be able to be used by astronomers for all kinds of work, whatever they need to look at in the visible spectrum. It's just going to be ludicrously powerful. You know, they should have called it the ludicrously large telescope. But anyway, one of the capabilities is that it will theoretically be able to distinguish between stars like the sun and planets like the Earth that are orbiting around them within a few dozen light years of us. And so once we have potential candidate stars where we know that there's a planet there, the Extremely Large Telescope should be able to detect the presence of the atmosphere of those planets orbiting around those stars. But this is at the very limits of what this telescope is able to do. But in general, when you think about all the pretty pictures that you get from the European Southern Observatory and the Very Large Telescope, or the Keck Observatory, or the Gemini North and South, you're going to get this other monster telescope. And then sort of showing up at roughly the same time is going to be the Giant Magellan Telescope, which is going to be more in the 30-meter class range. And it's going to be also sort of operating in the same area. And so we'll have 2 mega observatories in the Southern Hemisphere. Unfortunately, we won't have one of these in the Northern Hemisphere. It was planned that you would get the 30-meter telescope operational in Hawaii, but because of the protests, they've decided to change the location, and it will probably get built in the Canary Islands, but they haven't broken ground and really haven't gone ahead yet. You know, the Canary Islands are a very good place to put a telescope. They're the second best place to put a telescope in the Northern Hemisphere. The first best place is definitely Hawaii. So am I excited about this telescope? Absolutely. I can't wait. And we're only like 2 years away from that one. This year, I'm going to be obsessing about Vera Rubin, but next year, I'm going to be starting to get super hyped about the Extremely Large Telescope. Zapfan, thoughts on Eric Schmidt's 3-meter private space telescope project? So this is a telescope that we reported on last week, the Lazuli telescope, and this is being funded by Eric Schmidt, who is the ex-CEO of Google. And this is just one telescope that he is proposing. He's actually funding 4 different telescopes. This is the space telescope, but he's also funding 3 ground telescopes. What are my thoughts? Awesome. Yes, do it. Come on, fund it, make it happen. What's the matter? Are you scared? Fund it. You're a billionaire. Spend your money. Make science better. We look at some of the billionaires who are spending their money on building rockets, which is, you know, that's fine. We need rockets. But the downside of all of those rockets is that they're causing more light pollution, and it's going to make it harder and harder for astronomers to be able to do their work. There was like an announcement. I think China is planning a new constellation of satellites that's going to be very big. And so you're just getting, eventually, there's going to be hundreds of thousands of satellites. Like, it's just inevitable at this point. People want to communicate around the world. These things are going to just keep rolling. And so if one of these billionaires is going to be spending their money on a telescope that is above the atmosphere, that flies out pretty far away from the Earth above all of the satellites, that would be terrific. But I am kind of like jaded and cynical, right? Like, we went through the Project Starshot, where in theory, there was going to be $100 million that was going to be deployed, given to scientists to develop the underlying technology for the breakthrough Starshot, powerful lasers, solar sails, all that kind of stuff. And it didn't happen. That, you know, a few $1 million was allocated to various scientists, and then the whole project was quietly shut down. Building space telescopes and even just ground-based observatories is really expensive. You're not getting out of this with less than several $1 billion. Like, maybe you can do this for cheap, but you're probably going to be spending hundreds of millions, if not billions of dollars to make this mission come together. And you're going to get scope creep and the project, pardon the pun, and the project is going to get expensive, and you're going to have to keep writing checks one after the other to make this thing come together to make that vision a reality. And that's why traditionally telescopes are done by countries, because they are incredibly expensive. And really, it's only the assets of a nation state that is able to sort of realize a project on that scale. Regular people don't have the stomach or the assets to be able to buy a telescope that's, it's worth that much money. Even the Elon Musks and the, and the Peter Thiels and so on of the world, I think they'd have a hard time funding out of pocket what a space telescope would cost. They're all pretty stretched. So do I think it would be great? Yes, please, more telescopes. Come on, billionaires, spend your money on science and making humanity better. How's that coming? Disasterina. Would the primordial black holes in the early universe have evaporated by now? How long would it take? So right now we know of one way to get a black hole, and that is to explode a star. And, you got to have a star that's about 25 times the mass of the sun. And then you're left with a black hole of several times the mass of the sun. And then that is the beginning that you can then accrete more material, and your black hole can get stronger, and black holes can find other black holes and merge together. And theoretically, that's how you get supermassive black holes. It's also possible that you could get supermassive black holes through direct collapse. You just have a giant cloud of gas. Under its own gravity, it starts to pull together and can turn into a supermassive black hole. But there is this sort of lower limit on what is the smallest possible, the least massive possible black hole. But there's been this idea kicking around that there could be primordial black holes, that in the early universe, the regions of over and under density moments after the Big Bang were so great that you just got black holes of all different sizes forming just naturally. That it's just space was so close together, energy was so close together. You had little Kugelblitzes everywhere, and they could be all kinds of different masses. Some could just be the mass of a few hundred atoms. Some could be 1,000 times the mass of the sun and would be still living to this day. And then all of these black holes would go on to evaporate. And as a black hole becomes less and less massive, it evaporates more quickly. And so people have done the math, and I forget the exact number, but it's like about 100 million tons, I think, that if you had a black hole that was, roughly the mass of a small asteroid, it would have evaporated by now in the universe. And then anything with more than that is still able to maintain some of its mass and wouldn't have evaporated yet. And so people have made this calculation and determined the amount of sort of how often you should see gamma ray flashes. And it was believed maybe that one of the explanations for gamma ray bursts early on was that these were primordial black holes evaporating and going through their sort of final death flash. Now we know that they're caused by really massive stars that are collapsing, but there was a real serious theory, and you can't rule it out. So people continue to wonder if there are primordial black holes, and they are looking for the flashes of radiation that would come from the smallest black hole, the least massive black hole evaporating. And then the next least massive black hole will evaporate, and then the next least massive one. And so over time, all the little black holes will evaporate. It's time to shout out our new patrons at the $5 level and above: Sun Voyage, Tobias Carlson, Evan.pro, SPQR, Scott Ohms, Jonah Kaufman, 740, Steve Kennedy, Zeldaborg Galactic Defender, and David Butler. Join our community at patreon.com/universetoday. Gadzooks, has AI released any good scientific papers yet? I don't think that's a great way to sort of think about it, because the answer is no, and absolutely not. The AI is terrible at writing things and putting thoughts in this kind of logical way and presenting. And there's like a ton of AI slop that people are finding on arXiv and various scientific journals. And I think that's because the people who are using it are making a big mistake, which is that they're trying to get this thing to write for them. They're trying to get this thing to just do a science. And instead they should be using these as tools to help them with their work. And so there are apparently a bunch of really challenging math problems. I forget the name of them. Something. Someone in the chat is going to remember this. But there are these really challenging math problems and there's like 700 of them. And they, if you really want to sort of prove that you're a math genius, you can go and take on some of these problems. And now they're starting to fall. So some of the most challenging math problems are now being solved by a mathematician who is using AI as a tool to help them iterate through the various calculations that they're looking to do. And that feels like it's a much better use of this kind of thing. Like, you're the mathematician, you know how to do the work, you know how to logically think about the kinds of problems, but sometimes the solution is going to require somebody to search a space of possible solutions that is too big for a human with a pen and paper, or even a human with a calculator to be able to accomplish. But you can sort of take the AI and work with it hand in hand to be able to accomplish these kinds of tasks. And so I think, like, a lot of people saw the magic trick of a talking computer, and they're like, well, this computer can talk, I'll bet it can think, right? I'll bet it can do anything. And it can't. It can do very specific things, and some things it can do very well, and other things it does really badly. And I think that people didn't take enough time to digest what this is really capable of doing. I think we're now at the point where nobody argues that this is revolutionizing the way coding gets done. That now software engineers, you don't hear a lot of software engineers who say, yeah, I don't really see the value of these coding tools. Like, they are really powerful, and they really magnify your ability as a coder to put out useful software. But the software has a lot of problems. And so you, as a software developer, have to know the kinds of problems and put it in the right framework and give it the right kind of scaffolding so that it can actually accomplish jobs. You're there helping to develop the plans. You're there to make sure and do the acceptance testing and make sure that what it's doing isn't slop and garbage, but it is delivering actual results and producing code that is able to be put into production. And that's just going to accelerate. Like, we're finding this whole field is accelerating faster and faster. And so I think we're not going to see like actual scientific papers written by AI probably for a few years, but we're going to see big chunks of the grunt work written by a team of scientists done with the assistance of the AI. To explore these sort of concepts for them to be able to come up with an answer. So it is going to revolutionize science, just not as easily and as quickly as I think everyone was hoping, that you could just like, hey, talking computer, do a science. You got it, boss, right? We're not there yet. Dream Shizo, what's more scary, finding aliens or never finding them? Yeah, so there's a classic quote by Arthur C. Clarke where he says, two possibilities exist. Either we're alone in the universe or we're not. And equal possibility is equally terrifying. And think about the two possibilities. Either we're alone in the universe, that of the hundreds of billions of stars in the Milky Way, of the hundreds of billions of galaxies in the universe, giving you whatever, quadrillion stars and their planets, life only happened once. And intelligent life only happened once. And that's us. And here we are standing at the precipice of both our ability to explore out into the cosmos and our ability to destroy ourselves with all kinds of elaborate tools, bioweapons, nuclear war, climate change, various environmental catastrophes. Like, there's a lot of stuff that we can do. Or we can make the leap off into space, and that we can be the beginning, the seed that turns into the tree of life that spreads across the cosmos. But that is terrifying because the pressure is on us to do this. That if we don't pull this off, that if we give in to whatever is the darker side of our nature, then we will fail. And then it'll be up to the dolphins or the octopuses or, what is this, a slug maybe? So that's the one side of the question. And I find that terrifying. I do. The other possibility is that we are not alone, that we are just one tiny cog in a vast universe that is filled with life, and that life is diverse and it has a variety of different goals. Some of them are very benevolent. They just want to get along, man, and they just want to be our friends. But then there's others which could be malevolent, that they want to acquire more territory. They see us as resources for fuel for their own conquest, that they want to colonize the solar system in sort of the way that humanity has colonized civilizations in the past, in the bad way. And so that if there is life, lots of life out there, then it's all unpredictable. And, we don't get the clockwork movement of planets around stars and stars around galaxies and clouds of gas, and everything is understandable, and we just slowly expand out into the cosmos, that we get this rough, chaotic, complex universe that is filled with cultures that we don't understand, and that we are stumbling our way into this, and that as we pop our head out the door and look around, that these civilizations are going to take notice. And that is scary too. So which one do I find more terrifying? I think I find us being alone more terrifying. I think I would prefer, if I had to choose, like if you just said, okay, Fraser, you get to choose, which one is it? I choose the universe that is teeming with life. That, like, as soon as we fire our warp drive for the first time, the Vulcans are going to show up and they're going to invite us to the Federation, and we are then going to learn about the wider cosmos. That would be my preference. But, if you've watched enough of my videos, that is not my opinion. That is not what I sort of believe to be true. But, I'll have evidence either way. So, it is a chilling dichotomy to think about both versions of that. Murky waters. Is there a point where a black hole can reach critical mass? And if so, what would happen? So if I understand the question correctly, you're wondering, if you just keep feeding a black hole with mass, will it reach some point where it's just full, it's stuffed, and then if you feed it one more little bit of food, then it'll explode or something? The answer is no. There is no maximum amount of mass that you could feed to a black hole. You could feed a black hole all the matter in the universe, in the observable universe, all of the photons, all of the light, all of the dark matter, all of the gravitational waves, everything, and it would just say, please, can I have some more? That's just the reality of black holes. So they don't get pushed to their breaking point. The reality is the only way to kill a black hole is to starve it, because even just the background radiation of the universe is constantly falling into these black holes and is making them bigger. So you have to put a black hole into a freezer, a dark freezer where no radiation can reach it. And then it will slowly evaporate over enormous periods and eventually evaporate down to almost nothing. And as it does, its temperature will increase. And in the final moments before it disappears, it will explode in a flash of gamma radiation. So that's it reaching critical mass, I guess, is that it is starved to death and then it explodes. But not a very gigantic explosion compared to the amount of mass that it started out with. I'm going to talk about how to see auroras, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Barely Groofing, Brian Bodie, Caradwan, Chuck Hawkins, Commander Balok, Cy Nelson, Darkfinger, David Gilton, David Matz, Evan Pro, Greg Feely, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Smith, Michael Purcell, Nordspace, OneStepForAnimals.org, Paul Roebuck, Brink Haidu, Richard Williams, Sean Sargent, Stephen Fowler Munley, Team 49, Telescopes Canada, Wolfgang Klotz, and Zeldebor Galactic Defender, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So hopefully, at the time that you're watching this, there is a new set of auroras that are sweeping past Earth. That's because there was an X1.8 flare on the surface of the sun. That means we get increased aurora activities when all of the radiation and particles make their way to the Earth. And my social media feed has been filling up with people sharing pictures of the auroras. As far south as places like Georgia. So definitely visible here in Canada. And if you've never seen an aurora, we're now in solar maximum. And so this is the best chance that you're going to have to be able to see the auroras. And then over the next year or so, the activity is going to die down, and then it's going to go to solar minimum, and it's very unlikely that you'll see auroras, and then it will rise back up. And then many years from now, we'll be back in another solar maximum. So right now, how do you see the auroras? Like if you're watching this on the Tuesday that we're releasing this QA, how do you see them? So there's a couple things you need to do. First is ideally you need to get some kind of tool that will give you an idea of whether or not there is aurora activity in your location. And people always want my recommendation, and I don't have one, but there are a ton of them. Something which will show you a map of the world, show you where the current high amounts of aurora activity are, see if that map overlaps where you live, and if so, then you can see auroras. Now, you're not guaranteed to see auroras, but you can see them. But then if the strength increases, the likelihood increases, then it just gets better and better and better. But I think that whenever there is a chance of seeing an aurora, you should try, because you never know what is going to happen. Some of my best aurora experiences happen when the activity was actually fairly low, but still possible. And we just really lucked out. And so you miss 100% of the auroras that you don't go out to try and watch. So you need to, ahead of time, find a location that gives you a view in the direction of the pole. So if you live in the northern hemisphere, you want to be able to look towards the North Pole. If you live in the southern hemisphere, you want to be able to look towards the South Pole. You want a place that is as dark skies as you can get. If you live in a city, you're going to need to map out. And there's a website called the Dark Sky Finder that allows you to see the light pollution, and you can sort of compare places around you that are going to give you nice dark skies. But you're going to need to sort of, through experience, figure out what is the place you want to go to be able to observe dark skies. And you're going to use this for all kinds of stuff like meteor showers, comets, and auroras. This is going to be your go-to place. And hopefully it's got a view that is dark in the direction towards the pole. So in my case, I live on Vancouver Island. I can go out to the coast onto the eastern side of Vancouver Island. That allows me to look north. I've got ocean between me and the mainland. I can look towards the north, and it's totally dark skies towards the north. And so that is the place that I can go if I'm not lazy and I just watch it from my backyard. You want to dress appropriately for the night, and overdress appropriately for the night, because it can get very cold. And so just think layers. Bring a sleeping bag, bring hot drinks, because you're going to be there for a while. And then really, you have to be patient. That these auroras can appear out of nowhere, and they can last for minutes or they can last for hours. You have no idea what's going to happen. And so you've got to be with a bunch of people who have the patience to be able to watch it. Kids are tough. Meteor showers are great because the meteors come once every minute. But auroras, you could just go there for the whole night and not see anything. Or you could go there and within 5 minutes, you could see something that will change your life. So find a way to keep notified of what's happening with aurora activity. Find a place that you can see dark skies that ideally allow you to get outside of all of the light pollution in your area. Pack for the conditions you're going to expect, and bring companions who are going to make the experience exciting and fun for you and them. All right. Let me know in the comments if you got a chance to see the auroras this time around. I'm guessing a lot of you did. They're pretty great. All right. We'll see you next time.